esteemed chief guest Professor Muhammad Mubin, Vice Chancellor of Cluster University of Srinagar, Jammu and Kashmir. Professor Mubin is a distinguished academic, visionary leader, and stalwart in the field of chemical sciences. His groundbreaking research, innovative thinking, and passion for mentoring have inspired countless scholars worldwide. Sir, we are deeply honored to have you here with us. We eagerly look forward to your enlightening words, which will surely broaden our perspectives and motivate us to strive for excellence. Please join me in welcoming Professor Muhammad Mubin to deliver his insightful lecture.
इस पे हाँ अच्छा नहीं दे हाँ दे दीजिए मैं इससे कर लूँगा ये ओके वो निकालिए Shall I start now? Yes. The topic for today's presentation is sustainability in corrosion inhibition, current practices and future prospects. You know, as I told you in the inaugural function that corrosion is an interdisciplinary subject, so don't think that it will not interest you. I will give a very simple example to prove that how interdisciplinary is and what type of people are interested in this subject. You know, I will give the example of my journey into this research. I am a master in organic chemistry. When I joined research, and at that time there was a project from Department of Atomic Energy, then I saw the advertisement and applied for that. And the candidate who was supposed to apply, they were asked, the qualification was Masters in Chemistry, Masters in Physics, Master in Metallurgy, Master in Chemical Engineering, Master in Electrical Engineering. So these were my early exposure to the subject. Being an organic chemist, I traveled into a field which was mostly devoted to engineering subjects and different types of engineering subjects. And when I submitted my PhD thesis, the examiners were, my internal examiner from India was was from electromed division. So just you see the diversity. And my foreign examiner was from electrical engineering department from USA. So this is not the property of a particular people from a particular subject. Uh, People from different aspects can enjoy this topic. Next slide. Before coming to that, I would like to give some data, some facts about corrosion. Corrosion is as old as human civilization, though it has been known by different names. And this, it find an early mention as early as 2379 by a Roman philosopher Pliny, who for the first time wrote an essay, Ferrum Compita, slightly word meaning iron rusting. And corrosion is a natural phenomenon. It is bound to happen. It is bound to happen. Just like any other natural phenomena. For example, I say that water flowing down the hill. It is bound to happen. पहाड़ से नीचे पानी गिरेगा है ऊपर नहीं जाएगा तो it is similarly corrosion is bound to happen and to many people corrosion means rusting though rusting is not all corrosion rusting is a specific word which is specifically reserved for the corrosion of iron or steel in presence of moisture. And there is a formation of rust that is hydrated ferric oxide, this red rust, that is why it is known as rust. So this is exclusively reserved for iron corrosion, and it's not, but corrosion is not restricted to metals only. It involves other materials also. For example, there is corrosion of plastics, corrosion of polymers, corrosion of ceramics, corrosion of glasses. But the subject of metallic corrosion has found attention, wide attention both in academia and industry, because the metals are being used as engineering materials since centuries. That is why they have found wide attention both in academia and industry. Whereas subject of other material corrosion, for example, plastic corrosion, polymer corrosion, has not rubber corrosion, has not found the same understanding and sophistication as the subject of metal corrosion because plastics and polymers are probably relatively new material, new engineering material, new entrant in the field of engineering material in comparison to the metals. Um, uh, Corrosion is now expected but preventable. All known materials are susceptible to corrosion. Not a single material is available on the earth which is not susceptible to corrosion. So this is a very important fact. Uh, though it is reserved for metallic alloys, corrosion also involves huge economic losses. Huge. When I'm saying huge, it is not sir, छोटा नहीं है, बहुत बड़ा loss. That is in the order of 3 to 5% of national or global GDP, which is a very huge amount. I will give data. I will talk about that. And probably the economic classes is the prime motive for much of the current researches in the field of corrosion. Next fact which I would like to highlight that corrosion is posing a potential risk for availability of metal for future generation. If we are not able to check corrosion unabated, if corrosion continues unchecked, then probably we will not have metals for future generation. This is a fact. Uh, corrosion and corrosion mitigating processes are also polluting environment, polluting air, polluting soil, polluting water. And another fact about corrosion is that corrosion cannot be stopped in most cases. अगर हम ये कहते हैं कि we can stop corrosion, this is not true. It can be minimized, rather it can be controlled to some extent. As well as it will get time, its suitable environment, it will again start. The next slide, please.
Sir, excuse me. Sir.
Did you know corrosion? That is a huge. When I was saying about huge economic losses.
Online नहीं जाना सर यहाँ.
अच्छा चलिए ले लीजिए. When I was saying that huge economic losses, to see that the cost of corrosion is that this is the latest data, that is $2.5 trillion annually. That this is about 3.4% of GDP. India alone is losing 4.2% of GDP, and the GDP for India, projected GDP for India in 2024-25 was 311 lakh crore. So you can just calculate the amount of loss due to corrosion. And this corrosion doesn't include, this is the direct loss due to corrosion. Direct loss का मतलब ये कि suppose some structure has, some pipeline has corroded and you have to replace that pipeline. Yeah, some other structure has corroded, you have to replace that structure. So this involves only the cost of replacing the corroded structure, or if you will be using extra corrosion resistant material in place of that, that include that cost. And it doesn't include the cost which may result due to the loss of health and life because of the failure of the critical part of the component of an industry in an industry. So this doesn't include that. And by using whatever available resources are there, techniques are there, at least we can significant control corrosion to the extent of 15 to 35%. Next, please. Why prioritize corrosion research? So for me or for anybody, corrosion is not just a technical pursuit, but it is a vital investment in future. By prioritizing corrosion research, what we can do, our corrosion research, our innovation in corrosion, we can promote economic sustainability without affecting the environment. And second, we can protect critical assets and foster a safer and more sustainable world for future simply by preventing catastrophic failures in the plants. And third, we can support environmental sustainability through the development of green and eco-friendly solutions. And in this way, probably we will be able to save metals for future generation, and at the same time we will be able to save water resources and energy resources associated with the production of metal. Next, please. Corrosion research in India, a key to saving billions. Just I told you that it involves huge economic losses, and India's GDP, projected GDP for 2024-25 is 324.11 lakh crore. And this estimated cost of corrosion is approximately 4% of GDP. So this comes about 13 lakh crore. The loss due to corrosion in 2000, agar if you calculate 4%, this is about 13 lakhs crore, and education budget for projected for 2020 India government allocated 1.48 lakh crore for education, employment and skilling. And if you compare and highlight this financial loss with the allocated education budget, so this is nearly 9 times, the corrosion losses is nearly 9 times the budget allocated for education, employment and skilling. So simply you can judge the importance of prioritizing corrosion research. By prioritizing corrosion research and corrosion mitigation practices, we can at least we can spend more in education, skilling and employment. Next, please. There are different methods, different practices to protect metal from corrosion, but I will talk only about inhibitors, because we are going to talk about sustainable practices and inhibitors. What are inhibitors? Next, please come to next slide. Corrosion inhibitors are chemical substances, and probably use of corrosion inhibitor is one of the most widely used industrial method, where chemicals are added into the process stream, where they get dissolved into it and protect the metal from get adsorbed on the metal surface and protect the metal from corrosion. The basic principle of protecting metal from corrosion is that anyway you have to cut the contact between the metal and the environment. So in this, when we are adding corrosion inhibitors, for example, certain chemicals, they get dissolved into it, form a adsorb layer at the surface of the metal and cut off the contact between the environment. And they form three different types of layer. Either the chemicals added form a passive film, oxidize the metal and form a passive film. For example, chromates, etc. They form a passive film, or some inhibitors, they get precipitated at the metal surface and protect the metal from corrosion, or they form adsorption film. Next, please. Timeline of evolution of corrosion inhibitors. Prior to 20th century, use of natural substances like wax, oils, and greases were very common. When since early civilization, we have been using this practice, and still it is being followed in our household, that metals are protected from corrosion in this way. So already we are following sustainability. And early 20th century saw the development of organic corrosion inhibitors, and that were mainly amine based inhibitors. And one of the disadvantage of amine based inhibitors was that though they were efficient, but they were highly toxic. The mid 20th century saw again the development of inorganic inhibitors, for example, chromium based inhibitors and some heavy metal based inhibitors. They were excellent in protecting metal from corrosion, but again, the disadvantage was that they were highly toxic in nature. The late 20th century saw the emergence of environment-friendly corrosion inhibitors, which were alternative to toxic corrosion inhibitors. And 21st century saw the increased emphasis on biodegradable and sustainable corrosion inhibitors. Next, please. Sustainable practices in field of corrosion inhibitors. Why sustainability is important in corrosion inhibition? Because of the environmental concern due to the use of traditional corrosion inhibitors, which are quite toxic in nature. And of course, societal concern because of the huge economic losses. Key element of sustainability is that we have to shift towards eco-friendly and biodegradable alternatives, use of green inhibitors derived from natural sources, and adoption of renewable feedstocks, and implementation of circular economy principles to reduce waste and enhance recyclability. Next, please. Applying circular economy principles to corrosion inhibition, that's the use of natural feedstocks. Nowadays, people are concentrating using plant extracts, agriculture waste like rice husk ash, sugarcane bagasse, coconut coir dust, animal waste, and a lot of paper are coming nowadays, like eggshell waste, bone extracts, fish scales, waste from slaughterhouses are also being exploited as corrosion inhibitors. And industrial byproducts, for example, molasses are being used as corrosion inhibitors. And recyclable formulation for recovery and use, for example, chitosan inhibitors and surfactant-based inhibitors are being used. Digitization and monitoring is also helping. For example, sensors for precise inhibitor application. Now we have sensors. For example, you see that what is happening in any process, for example, in refinery, a petroleum oil refinery, uh, inhibitors are continuously added whether the corrosion is taking place or not, in anticipation that if ever corrosion will happen, it will protect the metal from corrosion. So what we are doing, we are putting a lot of chemical into the system without using that chemical. So because with the use of sensor for precise application, we can detect when corrosion is going to happen, and the inhibitor will be in place only when there is initiation of corrosion. So, in this way, we will, we can, restrict the use of inhibitors. We are not going to, use inhibitors at our own at our own will, and we will use only when it is required. Use of AI predictive maintenance, predict when and where corrosion might occur. High throughput screening, predicting properties, and molecular designing with machine learning. नेक्स्ट प्लीज. इन्वायरमेंट फ्रेंडली, इससे पहले छूट गई, देखिए, गो बैक टू. हाँ, evolution of sustainability in field of corrosion inhibition. Early awareness was use of natural substances. Another step was taken, that is harmful chemical bans during the period 1980s and 90s, and that growing environmental concern led to the ban of toxic inhibitors like chromates and heavy metals. Now they are completely banned. Now, although still some of the companies are using, कहते हैं ना चोरी छिपे यूज कर रहे हैं, only because of the fact that they are highly efficient in protecting metal from corrosion. But because of the ban during the period, this ban has started from 1980s. But you see that how difficult it is to phase out these chemicals from the market. Adoption of green chemistry since 2000s, shift towards natural and plant-based inhibitors. A lot of researches are being carried out, on tannins, fluorides, and all these things, and research on biodegradable polymers and surfactants. Technological advancement, since 2010, exploration of nanomaterial based eco-friendly corrosion inhibitors are used for precise application, and global recognition since 2020s onward and present, integration of sustainability into corrosion standards. These are the standards, ISO and NES framework. NES is the National Association of Corrosion Engineers, and AMPP, now NES has been renamed as Association for Materials Protection and Performance, and they have introduced this standard only in 2024, that is Material Sustainability Framework based on corrosion management system. And nowadays another step has been taken, that expansion of funding for green corrosion research. If you are submitting a project on green corrosion research, that there is high probability of getting funds for that. Next, please. Environmental friendly corrosion inhibitors, of course, those inhibitors which are non-toxic, biodegradable, and have minimal bioaccumulation are defined as environment friendly corrosion inhibitors. Examples is listed there. Synthetic corrosion inhibitors synthesized using eco-friendly solutions. बढ़ाने के लिए synthetic corrosion inhibitors synthesized using eco-friendly approaches are also known as environment-friendly corrosion inhibitors. I will give one data. You will see the importance of growing interest in environment-friendly corrosion inhibitors. We have data from 1980 to 2000, and during that 20 years period, out of total publication on corrosion inhibitors, only 10.69% of papers were devoted to environment-friendly corrosion inhibitors. There was not much interest in environment-friendly corrosion inhibitors. But look at the data from 2000 to 2024, there is a quantum jump on the publication devoted to environment-friendly corrosion inhibitors, 6-time jump from, that is now the total paper appeared on environment-friendly corrosion inhibitor is approximately 66%. So there is a growing interest in research on environment-friendly corrosion inhibitors. Next, please. Assessment of environment-friendly corrosion inhibitors, OSPAR and REACH Commission, they have defined which compound will be designated as environment-friendly corrosion inhibitors. And it's based on assessment is based on bioaccumulation ability, biodegradability, and impacts of its toxicity on environment. Toxicity corrosion inhibitor with ratio of LC50 to EC50 value greater than 10 milligram per kg is considered as non-toxic. Biodegradability corrosion inhibitor which decomposes 60% or more in 28 days is categorized as environment friendly. Bioaccumulation corrosion value is partition coefficient value equal to or less than 3 is categorized as environment friendly corrosion inhibitor. Next, please. Development of environment friendly corrosion inhibitors. Both type of compounds have been developed as environment friendly corrosion inhibitors. In organic based compounds we have rare earth metals, they are green in nature, and organic based compounds where again we have both natural as well as synthetic. In natural we have extracts from the plants, for example extracts as well as oils, amino acids and biopolymers which are being currently exploited as corrosion inhibitors. And in synthetic we have surfactants, ionic liquids, drugs, synthetic polymers and carbon dots. These are also somewhat environment friendly in nature. Next, please. This is the literature spanning past 2 decades on various classes of green corrosion inhibitors. If you look at the total number of publications, this is Scopus data, 26% highest number of publication on green corrosion inhibitors is on drugs, 26%, and that was followed by surfactants, that is 22%, and plant extract 20%, and amino acids 17%, and rest are other compounds. Next, please. Plant extracts as corrosion inhibitors. Plant extracts have been nowadays, huge number of papers are coming on plant extracts. Plant extracts means every part of the plant, extract of every part of the plant, whether it is flower, it is bark, it is stem, it's leaf. All extracts of all part of the plant have been exploited as corrosion inhibitors, only because of the fact that why they are acting as a corrosion inhibitor, because these extracts from the plant, they contains phytochemicals which are complex organic species, and they have electron rich centers into their structure. With the help of that they get adsorbed onto the metal surface and protect the metal from corrosion. And out of these all extract, leaf extracts are probably, they are showing more efficiency and they are more popular because phytochemicals are stored into the leaves. So that is why concentration of phytochemicals is higher in the leaf. That is why leaf extracts are showing higher promise in corrosion inhibition. Next, please. Advantage of leaf plant extract is that they are environment friendly and biodegradable. However, disadvantage is that still we could not commercialize plant extract as corrosion inhibitor for the industry. इसके लिए आड़े क्या चीज आ रही? What are the why it's being hindered? Because low protection efficiency at optimum concentration. For high inhibition efficiency, you have to put large doses of inhibitor. So of course the process will not be economically feasible, because for example to obtain optimum efficiency, if you are putting more inhibitor into the system, so of course process will not be economically viable. Our extraction process is very exhaustive, and in some cases, plant extraction cases, we are using hazardous chemicals, for example some acidic and alkaline chemicals in their synthesis. And most of the plant extracts are liquid in liquid form, and they have a shorter life. Inka shelf life is very short, and at the same time there is another disadvantage, that their performance is not good. They break down at at elevated temperature. So now the emerging trend is कि just you change the structure of plant extracts by complexation with polymers and other materials, simplify the extraction process and make the process environmentally compliant, explore the possibility of reducing extracts in solid form. If we are anyhow we are able to produce extracts in solid form, so probably we will do away with the shelf life of that. And encapsulation in polymers to form composite materials. Next, please. This is the some publication we have published. Our group has published a lot of paper on this in some very good journals. Next, please. Amino acids as corrosion inhibitors. You know, amino acids, it's a simple molecules, and they have both the functional group NH2 group and carboxylic group, and because of their structure, because they have also heteroatoms in there, they have carbon-carbon double bond there. So because of this, you know, electron rich centers in the compound, they act as a corrosion inhibitor. And a lot of probably 20 amino acids have been exploited as corrosion inhibitor. Next, please. Advantage is that they are non-toxic, water-soluble, naturally occurring, biodegradable, and cost-effective. However, disadvantage is that their simplicity of their structure. The structure is so simple. You see that for efficiency, we need a complex structure. We need a large structure so that it can cover the large surface area over the metal and protect the metal from corrosion. Simpler the compound, more efficient it will be. So this is the drawback, that amino acids have simple structure. That is why, you know, they are not as efficient as they should be. Emerging trend is to alter the structure of amino acids by introducing phenyl rings, more heteroatoms, heterocycles, inclusion of varied length of hydrocarbon chain, and chemical functionalization of amino acids to produce polymers, surfactants, ionic liquids, and Schiff bases. Next, please. These are some publications on amino acids our group has published at Aligarh. Next, please. Biopolymers as corrosion inhibitors. Again, biopolymers, you know, what is the advantage of biopolymers? Biopolymers, you see that biopolymers are long chain molecules. You know, always, you know, as I told you, simpler the molecule, less efficient it will be. And of course, a larger molecule can replace more water molecules from the surface, making the process entropically favorable. So that is why they are more efficient in comparison to a single monomeric molecule. Next, please. This is advantage. They are cost effective, inherently stable, and non-toxic. Toxic. And already I have told you that the process is entropically favorable. And again, you see that what happened in inhibition, corrosion inhibition by inhibitors, there is two process continuously occurs, adsorption as well as desorption. Both the process are in dynamic equilibrium. And what happened, that if the process of desorption is slowed down, then system will be more efficient. And what happened in case of polymers, because of the multiple bonding sites and long chain molecule, desorption process is completely slow in comparison to the adsorption process. That is why they are more favorable. Disadvantage is again their low solubility, low thermal stability, and high inhibitor doses for optimum inhibition efficiency. Emerging trend is chemical modification, that is grafting, cross-linking, blending with other polymers, nanocompositing, pH responsive modification. Now a very modern technique has come out, and we have carried out two projects on this. You know, that is now stimuli responsive coatings. You know, we developed a coating where inhibitors were incorporated into it, and inhibitors will be released only when the coating will sense that corrosion has started occurring. It will not release in advance. It will release only when there is a initiation of corrosion. So we have developed in our lab
consideration of new synergism approaches. Next, please. This is some publication on biopolymers. We have published very good papers. You can see that on this subject. Next, please. Surfactant as corrosion inhibitors. Again, surfactants have been exploited as corrosion inhibitors because of their properties of influencing the properties of surfaces and interfaces. Geminis or dimeric surfactants are more important and appealing to the customers owing to their high inhibition efficiency and very low concentration. Next, please. Surfactants advantage is again, ease of production, cost effectiveness, relatively high inhibition efficiency, relatively low toxicity. However, disadvantage is that they are non-biodegradable. Now, emerging trend is to convert non-biodegradable surfactant into biodegradable surfactants. And in our lab, we have applied this technique. We have introduced ester group by converting. How it can be converted? To convert biodegradable surfactant into biodegradable eco-friendly compounds by introduction of cleavable ester bonds and carbonate amide linkage in their chemical structure. And recently we have published some papers on that. And another thing is synthesizing Gemini surfactant from natural building blocks like simple sugars and amino acids. Next. These are the publication on surfactants. Next, please. Drugs as corrosion inhibitors. Drugs have been exploited to the maximum as corrosion inhibitors because they are also complex compounds and they have multiple bonds through which they acquire high corrosion ability. Next, please. Advantages, they are derived from biologically and natural resources, offer environmentally sustainable alternatives as they are biotolerable, biocompatible, and non-bioaccumulative in nature. And their nature is also macromolecular nature. That is why they cover large part of the metal. Disadvantage is, of course, high cost. High cost because they are very costly. And the emerging trend is instead of using fresh drug as corrosion inhibitor, let us use expired drugs as corrosion inhibitor because when the drugs has expired, it is of no use. So expired drugs also have same efficiency as fresh drug. So one alternative is use expired drug. Next, please. These are some of the publication on drug molecules. Next. Ionic liquids, इसको कहते हैं, they are known as designer corrosion products because you can by simply changing the cations and anions by having definite numbers of cations and anions is the structure, you can designing ionic liquids according to your requirement. Next, please. Advantage called designer corrosion inhibitors as their inhibition effects can be suitably tailored using a proper combination of cations and anions. They have low toxicity, less hazardous influence on environment and living being, extremely low vapor pressure, will not evaporate and contaminate surrounding environment. One-step synthesis is most cases synthesis of IL using less non-hazardous solvent. In most cases, water is used as solvent for synthesis of ILs. Disadvantage is poor biodegradability of ionic liquids as they are mostly synthesized from non-renewable sources and their cost is high. So emerging trend is most abundant biomaterials such as amino acids and sugar substitutes are being considered as excellent feedstock for synthesis of ionic liquids. Next, please. These are some of the publications on ionic liquids. Next. Carbon dots as corrosion inhibitors, they are the new entrant in the field of corrosion inhibitors. And if you look, because carbon dots have low toxicity, good biocompatibility, and inert towards chemicals, that is why they have found application as corrosion inhibitors. Next, please. We are not going to discuss about mechanisms. Next, please. and the carbon advantage of carbon dioxide as corrosion inhibitor is they are biocompatible and they have low toxicity. They are versatile in nature and their cost effectiveness. And one of the most disadvantage of carbon dioxide as corrosion inhibitor is the question about their scalability. We are not sure that we will be able to put those who have worked on carbon dioxide, they know that their production, is difficult, in a large amount. We are producing carbon dioxide in fractions. That is why one of the drawback is their scalability. Durability is also a questionable, and their environment impact is still being studied. So application of carbon dioxide as corrosion inhibitors, where water, for example, it is being used in water treatment system, biomedical devices, food packaging materials, and marine environments. Next, please. Concluding remarks, corrosion inhibition is crucial for protecting infrastructure and ensuring economic stability. Sustainable practices in corrosion inhibition are essential to minimize environmental impact and reduce costs. Current practices such as use of green and eco-friendly inhibitors have shown promise in reducing environmental impact. It has been shown that these substances can be excellent options for replacing traditional toxic, harmful, and expensive corrosion inhibitors. But however, just in preceding slides, you have seen that there are, though they have been used as alternative to the toxic compounds, but still there are a lot of challenges which needs to be addressed before majority of this can be exploited on commercial basis. Still they are commercialized. One thing I must add, whatever green corrosion inhibitors you have seen, still we have not been able to commercialize them because of the obvious reasons. Already I have listed why. Continued research and development are necessary to further advance sustainable corrosion inhibition technologies. We still need to put more research into the sustainable corrosion practices. Next, please. Concluding remarks. Future prospects, development of novel environment-friendly corrosion inhibitors with high efficiency and low toxicity, life cycle assessment and eco-design consideration for sustainable corrosion management, predictive maintenance using AI to reduce waste, collaboration between academia, industry, and policymakers to promote sustainable corrosion inhibition practices. Next, please. This is the last part of our group, which has been working on this. Now some of them have left. They have gone, some China, some South Korea, somewhere, but still at least 4 are working in my lab. 4 or 6 still are, I think, so they are working there. Next. Thank you very much. If you have any question, if you have any query, please, you are welcome. माइक दे दीजिए प्लीज.
My question is that, sir, which physical property degrade through a corrosion?
Which, you see, so good question. As long as metal is concerned, देखिए, दो चीजें हमने बताएं कि every material known on the earth is subjected to corrosion. But now the visualization is different. For example, metal part, suppose the dimension of your metal is diameter is 1 centimeter square. Once corrosion starts, it loses its dimension. There is material loss. There is loss of material. You got my point in case of metals. But in case of non-metals, for example, polymers, and actually what is happening in case of metals, metal is reverting back to its natural state. You got my point? Why metal is corroding? What we do, the actual state, thermodynamically stable state of metal is not pure metal. It's some compound of the metal, that is ore form. which is in the earth crust, that is metal oxides, sulfides, carbonates, etc. And once it find, what we do, we convert metal from these ores by following different metallurgical operation. And during this operation, we put a lot of energy into it. But as soon as we make some articles from the metal and put it into the environment for use, it tries to revert back to its own natural state, which was thermodynamically stable, by reacting with the environment. So this is the cause of corrosion. But in case of non-metals, return to their original state is not apparent. What happened? The loss is not physical loss. Loss is in the term of loss of materials properties. For example, I will give one example of rubber corrosion. You can say aging of rubber. You must have read that when rubber tires are 3 or 4 years old, some of the constituent of the rubber, they reacts with the ozone present in the environment, and the loss in the form of properties, not in the form of material. I hope I answered your question.
Okay, sir. The next question.
You are.
How to protect that corrosion?
The basic thing is, basic corrosion, there are 7 or 8 practices which are followed to protect metal from corrosion. But all practices have the same principle: cutting off the contact between the metal and the environment. You put some barrier between the metal and the environment, because in corrosion there are two things: one is the metal, one is environment. So as long as you are cutting the contact between the metal and the environment by following whatever practice you are practicing, then you will be able to control corrosion. In simplest word.
Thank you, sir.
और भाई कुछ? देखिए उधर हाथ उठा रहे हैं जी सर. He is coming. हाँ, वो आप उनको दे दो. आप
Thank you for the lovely talk. I felt that it's oxygen which plays a major role in corrosion. Agreed, there are other factors also which lead to corrosion, but is it oxygen which is very crucial for corrosion of most material and all? And can we use some other gas to insulate machine parts and so on by cutting off oxygen?
This is practically impossible. Whatever system, whatever structure, whatever equipment, whatever we are going to make, that has to be, we are making it for the use of the human being, and we are not going to use it in other atmosphere other than the natural atmosphere. This is bound to happen. It is bound to come in contact with the oxygen. One thing I would like to add, to be very precise, you see that rule of nature, iron readily rust in atmosphere. When it put into the atmosphere, you put iron in your lawn, fresh polished surface, and next day you will find it rusted. You put into the lawn, and next day you observe it, find it rusted. It readily rusts in atmosphere. But gold, you have not seen gold, the precious metals, it doesn't rust in atmosphere. But contrary to that, if you put gold into the environment of mercury, it form amalgam, it rust. But iron doesn't rust in gold. So this is, everything is related with the thermodynamic principle. As I told you, those metals which was their native state, they try to revert back to that native state as soon as they found any suitable condition for that. So you cannot do away with oxygen.
Maybe we can't do away, but we can make shells where the main machineries protecting the shell which is
नहीं,
filled with
you can do everything, but what will be the use for that? If you want to make a window, or you want to make doors, it has to be used in contact. You are not going to use in isolated place. By isolating into the environment, it will be of no use. Equipment you can protect, but even the person who is working on the equipment, he will work in natural environment. A person cannot be put in an environment where there is no oxygen. How he will survive? So that this is the basic thing about that. जी कसीम साहब कुछ पूछ रहे थे.
थैंक यू सो मच सर, काफी अच्छा आपका टॉपिक रहा. ये सवाल ये था कि एब्जॉर्प्शन के अलावा कोई और मैकेनिज्म इसमें इन्वॉल्व हो रही है कि
हाँ, देखिए आपने स्लाइड ठीक से देखा नहीं. देखिए the chemicals which we have been using to protect metals from corrosion. तो देखिए 3 बेसिक प्रिंसिपल्स हैं. Either that chemical oxidizes the metal, and after oxidation metal form its own oxide, as happened in case of stainless steel. It formed in the stainless steel, chromium is there, differentially get oxidized and form a film of chromium oxide. And for that you need an inhibitor which has oxidation property, which oxidizes the metal. The one is a formation of passive film. Second is there are some compounds which they themselves get precipitated over it. For example, phosphonates उसके ऊपर precipitate बना देते हैं और they cover the metal surface and protect the metal from corrosion. And there are certain chemicals, mostly organic compounds, they form an adsorption film. They get adsorbed either physically or chemically. Either there is a physis option or chemis option, and they form a protective film over the metal surface. There are 3 mechanisms by which they form a protective film.
Okay, thank you, sir.
जी मैम. As long as Salman Saab is
actually in continuation to his question,
जी
actually I am from astrophysics space background.
जी.
So supposing आपने चांद पे भेज दिया कोई instrument and you don't have an atmosphere, then you don't need to worry about corrosion, right?
देखिए practically yes, because there is no any ingredient which is going to affect it.
Exactly.
There is no question of happening.
तो वैसे चीजों में you don't need to worry about corrosion.
Yes.
So that's my worry.
But
that is my worry.
एक word caution आपने कहा था ना कि it's not necessary that one metal which is resistant in a particular environment will be resistant in another environment. We are not sure which type of environment exists in the space.
Okay.
So if there is any environment which is going to harmfully affect that metal, that will lead to corrosion. एक हमने गोल्ड का एग्जांपल दिया कि देखिए मरकरी में बहुत तेजी से करोड होता है, मगर एटमॉस्फेयर में बिल्कुल रस्ट नहीं होता. दैट इज व्हाई इट इज नोन एज प्रेशियस मेटल. हम बहुत महंगा है.
नहीं, बट स्पेसिफिकली आजकल आई मीन इंडिया, यूएस सभी जो आर्टेमिस प्रोग्राम है, इंडिया का भी प्रोग्राम है फॉर द मून, राइट? दैट इज द फर्स्ट स्टेप. तो उसमें देन वी डोंट नीड टू वरी बिकॉज़ यू ऑलमोस्ट कॉलोनाइजिंग द मून फॉर एग्जांपल, उसमें देयर इज नो वरी.
देखिए एक अभी हमने एक स्लाइड दिखाई थी, उस पे हमने बात नहीं किया कि कहते हैं कि जो करोजन जो है इट इज हैम्परिंग द एडवांसमेंट ऑफ द टेक्नोलॉजी. इट इज हैम्परिंग, कहीं आड़े आ रहा है हमारे जो एडवांसमेंट हम करना चाह रहे हैं टेक्नोलॉजी में, उसके कहीं आड़े आ रहा है करोजन जो है. बिकॉज एज वी गो ऑन मोर एडवांसमेंट एंड मोर एडवांसमेंट, you have to face more corrosive environment, and that is probably preventing the development of advanced technologies also. उसमें एक स्लाइड में मैंने दिखाया भी था मगर बात नहीं की थी आपसे. ठीक है सर.
Hello, sir. My question is that is there any microbe for the prevention of corrosion?
देखिए, yes, microbial inhibitors. देखिए क्या करें, बदकिस्मती है कि माइक्रोब्स को किल करने के लिए यू हैव टू पुट बायोसाइट्स. you have to put biocide. अभी एक हमने शुरू के inaugural function में हमने बताया था कि now there is very strict environmental regulations. The use of biocide has been completely it's a ban now to use biocides. What they are saying that you put some chemicals which is not as toxic as it's harmful to the environment. So what they are doing, for the growth of any microorganism, certain conditions are needed. Some condition is needed for growth of the microorganisms. That you have to work on that. That you have to work against that condition that don't provide favorable condition where that leads to the growth of organism. वो जब ऑर्गेनिक ही ग्रोथ नहीं होगी तो फिर वो करोजन क्या करेंगी. तो पीपल आर वर्किंग आउट. दिस इज अ कंटिन्यूअस प्रोसेस. देखिए एक चीज और करोजन रिसर्च में बहुत इंपॉर्टेंट चीज बताऊं कि अभी तक वी कुड नॉट इरेडिकेट. अभी एक स्लाइड में कहा था ना, इट कैन नॉट बी स्टॉप्ड, इट कैन नॉट बी कंप्लीटली स्टॉप्ड इन मोस्ट केसेस. हम कहते हैं ना कि इसको बिल्कुल खत्म नहीं कर सकते क्योंकि नेचुरल प्रोसेस कभी रुकती नहीं है. जब भी फेवरेबल कंडीशन पाएंगी वो शुरू हो जाएंगी. तो इसी तरह से ये इसका भी करोजन का है कि जो ही एक फेवरेबल कंडीशन पाएगा ये एक वक्त पे तो रोक देंगे आप, बट जो ही एक फेवरेबल कंडीशन पाएगा इट इज बाउंड टू हैपन. और साहब जी.
अस्सलाम वालेकुम सर.
अस्सलाम.
This is Dr. Arif. Sir, you have corrosion and everything. I have one clarification.
जी जी.
Definitely corrosion is the solution. Ligands you are reacting and doing, but my concern is when this corrosion is over, the ligands which binds with the metal.
Pardon?
Ligands bases, ship bases will bind with the metal and they will act as a anti-corrosive agent. They take away the metal ligation. But what is the fate of that complex? There is any solution? Because that again it will be the problem for the thing. When you do the corrosion experiment and after that you remove the solution with HCl and everything, then with ligands the metal will go away and your whatever the thing is anti-corrosive, either steel, iron, nothing. But what is the fate of that complex?
Actually, आपसे यही कहा था कि probably if corrosion is not checked, if continues unabated, बिल्कुल बगैर रुके ही चलता रहे, तो we are not going to recover that iron. There is a issue with the recovery of the item. क्योंकि वो कमर्शियली अवेलेबल, ओर्स आर कमर्शियली, कहते हैं ना कि ओर्स और मिनरल्स में क्या, मिनरल्स जो है कमर्शियली जो इसको एक्सप्लॉइट कर सके ओर्स को जो. तो फॉर एग्जांपल इफ यू आर लूजिंग मेटल्स ड्यू टू करोजन, यू आर नॉट गोइंग टू रिकवर दैट मेटल. तो इसीलिए कहा था कि प्रोबेबली वी विल नॉट बी एबल टू गिव मेटल्स टू आवर फ्यूचर जनरेशन. तो दिस इज वन ऑफ द बिगेस्ट कंसर्न कि आने वाले फ्यूचर में हो सकता है कि हमारे बच्चों को जो है, हमारे आने वाली जनरेशन को मेटल ही नहीं मिले. क्यों? कि बिकॉज मेटल रिसोर्सेज, वर्ल्ड सप्लाई ऑफ मेटल रिसोर्सेज इज लिमिटेड. ये तो सबको मालूम है कि लिमिटेड स्टॉक है हमारे पास. इफ वी आर नॉट डूइंग समथिंग इन दैट डायरेक्शन, तो प्रोबेबली देयर विल बी इशू ऑफ कंजर्वेशन ऑफ मेटल.
थैंक यू.
ठीक है सर.
Sir, one last question.
हाँ बेटा.
Sir, regarding MOF, I want to talk about. Sir, like copper substance, we make MOF. Iron substance, we make MOF. Combining organic compound. It's also a polymeric chain coordination polymer. Sir, can we put this MOF like a mitigating property in a? If we are making a substance of material, we are making material of iron and all. Just to avoid, just to make a fool of the environment, like.
No, you mean a replacement for iron?
Yes, sir.
You want to make? People are doing that.
Yes, sir.
Plastics, जो plastics के अब alloy बन रहे हैं. Now we have alloy. What was the limitation with the plastics? They were not heat resistant. They were not having the required strength. but that these are the days of the past. जो है ये पहले है. Now we are having plastics जो आप bullet proof उससे बन रहा है. Now they have exception. They have more strength than the metals. So this is one of the option. But still in spite of all the development in the field of plastics and polymers, still we have not been able to replace metals commercially in the industry. Still. Because why? अब तुमने पढ़ाया, मैंने corrosion पढ़ा तुमने, इसलिए because of economic consideration. If go on replacing your windows with gold, is it possible? It's no possible. It's not possible. If you are able to make a product which is competitive on price, price wise, then of course you can do that. Magar it's unfortunate that metals have still not been. कहीं देखा है, कहीं majority of बना तो रहे हैं लोग जो, but still structural material is iron. Structural material is iron, which is most corrupt, as long as corrosion is concerned.
Thank you, sir.
Sir, you talk about the ionic liquids. Sir, can we use because they are expensive, so we are not using them. Can we use deep eutectic solvents for this corrosion to inhibit the corrosion?
Which solvent?
Deep eutectic solvents. They are the sophisticated solvents.
No, I've not heard, I've not heard about those solvents.
So, sir, it is a spontaneous process. How can we stop it?
Corrosion?
Yes, sir.
The only एक ही इसका मंत्र है कि एक मंत्र आप खुद सोचो कि if there is no environment, favorable environment for that, there will be no corrosion. So only thing, कोई भी method है, there are other principles also. Just you have to use the principle of electrochemistry. Electrochemical phenomena है ना. और एक चीज जानते हैं कि in electrochemical phenomena, what happen? An electrochemical cell is formed, and when electrochemical cell is formed, anode is oxidized and cathode is reduced. So similarly, the part of the metal which becomes anode is corroded, and the part which becomes cathode is protected. So you can use that principle also. If you want to protect a metal from corrosion, make that part as anode or cathode. Automatically corrosion will stop, and this is being done by cathodic protection. This is being done by anodic protection. So methods are being carried out, but the only question is, जब आप industry में जाओगी, Salman साहब, the last answer I am going to give, what is the criteria for a material to qualify as engineering material? कोई भी जब इंजीनियर, जब आप कहीं हायर की जाओगी, अगर कोई पूछेगा कि क्या क्राइटेरिया होनी चाहिए इंजीनियरिंग मटेरियल की, द फर्स्ट क्राइटेरिया इज, फर्स्ट जो भी प्रोडक्ट बनाओगे, जब आप नौकरी में जाओगे, फर्स्ट प्रोडक्ट बनाओगे, आपका एम्प्लॉयर पूछेगा तो क्या बताओगे कि अनलेस एंड अनटिल इट इज इकोनॉमिकल, it has no use. You will not get any employment if you are making a product which is costly than a product available in the market. Nobody will purchase your product. So one of the basic criteria of research is the product which you are going to produce is economical.
Exactly. Thank you, sir.
I think we have addressed all the questions. Thank you all for your questions. Thank you, sir, for your enlightening lecture on sustainability and corrosion inhibition, current practices and future prospects, and patiently addressing all the questions. Your insightful lecture has broadened our understanding of this critical area and has truly enriched this gathering and has left us with much to reflect upon as we move forward in our academic and professional journeys. With this, our inaugural program comes to an end. A big thank you to each and everyone for your active and enthusiastic participation, which made this event a success. The technical sessions will commence at 2 p.m. sharp in the respective venues. Kindly refer to the conference program for details. Thank you so much.